The confirmation of the presence of sulfur dioxide ice on the surface of Europa, as well as other Galilean moons of Jupiter, has led astrochemists to speculate about its origin. For some time now, it has been suggested that sulfur ions originating in the Jovian magnetosphere may implant into the water ice-dominated surfaces of the Moon, whereafter they may react with radical species formed as a result of the irradiative processing of the surface, thus yielding sulfur dioxide ice. However, extensive laboratory implantations of sulfur ions into water ices have failed to yield any detectable presence of sulfur dioxide, with hydrated sulfuric acids being preferentially formed instead. More recently, it was suggested that the implantation of magnetospheric sulfur ions into minor surface components, such as carbon dioxide ice, may be a source of sulfur dioxide. However, experimental results in this regard have thus far proven inconclusive. As such, we have performed high fluence energetic sulfur ion implantations into carbon dioxide ice at 20 and 70 Kelvin, the latter being a reasonable approximation of the European surface temperature. We have found that although sulfur dioxide is formed as a result of sulfur ion implantation into carbon dioxide ice at 20 Kelvin, no signs of it were found after implantation at 70 Kelvin. This is most likely due to the fact that, at higher temperatures, the recombination of oxygen atoms to form molecular oxygen is more efficient. At 70 Kelvin, these oxygen molecules are able to efficiently sublimate out of the ice, thus leaving significantly less oxygen which may be used to form sulfur dioxide. Our results indicate that sulfur ion implantation is likely not a reasonable source for the SO2 observed on the surface of Europa, and that other mechanisms, such as the irradiation of endogenic sulfur-containing molecules, should be explored instead.